my burgers lasting years. I don't know if I want to.
Okay.
No,
I think we're okay.
You buy a burger at that moment because you're hungry.
Sure do hope we get the Tom Brady example. If not, we'll repeat it tomorrow. I'll check tonight. We can talk about it again.
Queue at 50 minutes and stop the Tom Brady giving it.
Tom Brady one's perfect though.
Yeah. Other important definitions and formulas that you will need to know through this section. This is like the biggest part of this section. It's just knowing all the definitions, but actually applying them is not that bad. You just need to know what they are. Cost, you can think of, you're usually thinking of cost in this way. There's what's called the fixed cost and variable cost. Fixed cost is cost that you have to pay no matter what, even if you're not doing anything. Like rent is a fixed cost, right? So you buy a store to sell your hamburgers, you're gonna have to pay the rent no matter what. That's just a cost that's there, it's constant, it's something you can apply for. Now the other costs come from actually producing items, right? So to produce those hamburgers, I have to buy a stove, I have to use oil, I have to use gas or whatever. You know, I have to have labor costs, which those will start to vary, right? So costs, you kind of think of them in two ways. Fixed costs and variable costs. Fixed costs are just costs that you have to pay no matter what, even if you don't produce anything. In fact, it's kind of the cost that you have when you don't produce anything at all. That's called the fixed cost. This is cost if costs that are always there, even if nothing is produced. Here, cost depending on how much you produce. So, and now you can sort of think of the context of marginal analysis, right? The idea is fixed costs, you can't really do anything about them, right? So hopefully you're making more money than your fixed costs, but then you have to worry about the variable costs, right? There's going to be a point, you only make money if your revenue minus your costs, right, is actually turning a profit, right? So the idea is your costs will grow based on this guy. That's a constant. That's just what it is. But variable costs can grow. The more you produce, the more labor you have to pay for, the more equipment you have to get, right? So eventually this guy will start growing, and that's going to eat into the money that you have. There's going to be a point where you're going to break even, right? The point of a marginal analysis is to figure out where that point is, right? So the marginal cost function is that function that's going to tell you what producing one more guy is going to do. You just want to get to the cusp where one more guy is going to tip the scale where your revenue and your costs are going to switch. One is going to become higher than the other. So that's when you're going to sort of know where to stop production, right? So that's kind of the idea. So cost is a big idea. And then cost can be anything. Variable costs can also include like taxes and stuff like that, which also depends on how much you're producing and selling. There's what's called the average cost, which is just the mean average as you might think. Which is just going to be, say, the cost function over the number of items sold. Right? C of x equals cost function. X is number of items. So there's the idea of average cost. Just take the cost over the number of items produced. That gives you the average cost. It's a notational thing that R of x will always mean the revenue function. This is earnings from producing and selling revenue. Here's also, you might want to talk about average revenue, which has the same definition. The revenue per item that you're selling. P of X will usually denote the profit function. Which basically equals to revenues minus costs. Right? How much money you're making minus how much you're paying, that's how much, that's your profit. Oh, by the way, there's the idea that the minimum average cost occurs when the cost to produce one more item hits the cost of production per item. Right? That's when it's going to change, right? Where the cost now is going to start exceeding the average amount of the average cost per item. That's actually that's actually the point you want to focus on. What else did I want to tell you? D of X is what's called the demand function. And these are all notations. In these contexts, whenever we're talking about economics, C we always refer to as cost, R will be revenue, P will be profit. D is the demand function, which is, in this context, we're going to look at it as the price per unit sold. Oh, price per unit one can sell. Sort of the demand for the object and for the product, and how much you can make from it. So this will be a demand function.
You said the derivative of cost is the same as marginal, right?
Yes, that's the marginal cost. The minimum average cost will occur when your marginal cost is equal to the average cost.
How does one actually find the demand function?
Huh?
How does one actually find the demand function?
You can find it empirically, which is why one reason in which real-world data, it's kind of hard to put in functions. So you just watch it over time. You track your products, how much you're selling, and you plot them. Day 1, day 2, day 3, day 4. You connect the dots, you get a function, right? Which might, who knows what formula that's going to follow, right? It's all about
you work
approximation.
backwards into the function.
You work backwards. Right? At any given time, you can't really tell the future. You're just tracking what has happened in the past and trying to use that to predict. Thank goodness, a lot of things are pretty predictable so far. One way you can think of revenue is as the number of products sold times the demand for the products. Another formula you might need to know is that for max profit, to increase your profits to the maximum that you can be. And we're going to talk about this when we get to optimization as well. You'll actually see how this is done, fleshed out fully step by step. You actually need your marginal revenue to be equal to your marginal cost. Finally, let's do an example. So we won't get to exponential growth and decay today. Just keep that, bring that handout back tomorrow. Cost in thousands of dollars first. So Q represents the amount of tons of copper we're mining out of some copper mine. And here's the function that describes that cost. And here are the questions. A, what is the fixed cost?
Pretty easy.
B, what is the average cost function? C, find the marginal cost function. D, find C prime of 100. What is its meaning? So here's a cost function, tells me how much it's going to cost me to extract Q tons of copper in thousands of dollars. What is the fixed cost? It's just 73, right? The idea is, of course, 73,000, right? Because it's in thousands of dollars. Right? It's just the guy that you plug in 0 everywhere else. Even if you don't extract anything, you still have to pay that 73. B, how do I find the average cost function?
It's the whole function of the 73.
No, it's the whole function over Q.
Over Q. So this is CQ over Q, which is going to be 73 over Q plus 0.6 plus 0.004 Q. C. What is the marginal cost function?
The derivative, which is 0.6 plus
Derivative. So it's going to be what?
0.6 plus 0.008 Q. Plug in 100.
Plug in 100. So C prime of 100 would be 0.6 plus 0.008 times 100.
1.4.
That's it.
So C prime of 100 is what?
1.4.
1.4. Right? Remember, you're thinking of this as in thousands of dollars. What does that mean? So if someone tells you this is a cost function and the derivative at 100 is 1.4. What does that mean? This is in thousands.
Does it mean that it would cost 1,500 to make 100 more?
It would cost roughly
$1,400 more dollars.
$1,400
Is it
to
The 100 item.
extract
the 101st ton?
one more ton after 100 tons have been extracted. So you already have 100 tons. Let's go for one more. It's going to cost you 14.
How does one find out what did the 100th ton, what was the marginal cost to extract 100th ton after 99 tons have been extracted?
Oh, it would just be 99. Plugging 99 into that function.
So that,
How does it actually compare? What's the actual cost of producing the actual cost for the 101st ton? What is the actual cost here?
Well, it's plug in 101 back into the original cost function.
That's the cost to produce 101 tons. I want the 101st ton.
Oh, right here.
you have to subtract the 100.
Yeah, you subtract the cost for the first 100. In this case, what would that actually be? I would be erasing that function.
It's 73 plus 0.6 cubed plus
0.3 plus 0.6 times 101
times
plus
0.004 cube squared.
101 squared minus
The same thing but 100.
that's 0.6 times 100 plus 0.004 times 100 squared. Where's that roughly?
Well, 101 squared is 10,201.
That's gonna be whatever. It should be close to that. We will stop there.
It should be close to what number you said?
Hopefully when you do all of this, should be close to that. 1400. Yeah, so we're done, unless there are any questions. I'll see you guys tomorrow, and
Do we have to do,
I didn't-
do we have to do 3.2 as homework?
yes, homework for this tomorrow. In fact, make sure you give me all the chapter 3 homework tomorrow, because we have to talk about it.
Even 3.6?
No, 3.6 is it's spilled over into the up to 3.5. Make sure I have that by tomorrow, because that's where the test is up to.
And what about 3.4? Today?
We